Today is yet another day on parallel and perpendicular lines. How do I identify parallel and perpendicular lines and write their equations? Your learning intention. I am learning to identify lines that are parallel, perpendicular, or neither from equations or from graphs. So you've got a warm-up question. The graph of f of x, the function f, when evaluated with x is x squared. If it is translated 4 units up and 5 units left, what is the equation for g of x if it is the translated graph? Pause the video and see if you can write that new equation. Okay, let's try. G evaluated at x is equal to, okay, to go 5 units up, that's simply a plus 5 on the end. We know that. To go left or right, we know it's in our parentheses. Now, I guess it's 4 units up and 5 units left. So to go up or down is a 4. 5 units left. Remember, this is opposite of what you think it should be. Normally, 5 units left means we're subtracting. If it is opposite, then we add. So our new equation is the quantity x plus 5 squared plus 4. Okay, pause the video and see if you can explain what's happened if the original graph was, your parent graph would have been, since this is h, let's use L, K. K of x would be equal to x. That would be our original because this is a linear equation. So let's break it down, see if you can pause the video and see if you know what's happened. Well, I hope you tried it on your own. The negative sign means it is reflected over the x-axis. That's your negative sign. Okay, I've multiplied by 2. What is that? Is it a vertical stretch or a vertical compression? A vertical stretch of 2. So now we've taken care of this. That's what those two things tell us. Okay, let's go further on. In parentheses, x minus 4. Remember, in parentheses, it is opposite of what we think. We're moving left and right opposite of what we think. So that would be shifted 4 units right. And finally, we've added 3 at the end. And 3 units up. Okay, negative means that you reflect it. 2 means it's a stretch. -4 in parentheses means it's going right. +3 on the end means it's going up. So what is the difference between a vertical stretch and a vertical compression? It deals with the numbers that you're multiplying by. Remember, a stretch makes it get bigger quicker. It's like pulling that taffy out. It gets really big, but it gets skinnier too. So a vertical stretch, how would you know if it was a stretch? We multiplied by 2, it was a stretch. Okay, if you multiply by a number greater than 1, that's a vertical stretch. Okay, so how do we make a number smaller? If I want to make something as a vertical compression, if it is greater, I forgot. If you multiply by a number greater than 1, I forgot the greater than 1. Shame on me. At least I had room to put it back in. Okay, greater than 1. It's going to get bigger faster. What would you multiply to make it smaller? Okay, you could say negative numbers, but that doesn't work in distance. What is something that we don't like to deal with a lot? Begins with an F. A fraction. So if you multiply by a fraction, we're going to call it a number because fractions are numbers. If you multiply by a number that is between 0 and 1, it can't be 0 and it can't be 1. It is a vertical compression. So, to make it bigger, any number greater than 1. To make it squished, a fraction between 0 and 1. Okay, find the line that is perpendicular to the given line and intersects the given point. Graph both on the same Cartesian plane. Okay, so first thing we have to do, let's just graph this one first. Remember, we're in that slope-intercept form. Y equals mx plus b. B is where we begin. Begin at 3. And we move. It's negative, so it's down 1, right 2. Where is 3 at? 3 is right here. I go down 1 and right 2. There's my new point. Can I do it again? Oh yes. I can do it till I run off my grid. Down 1, right 2. Okay, so this is our original equation. Okay, how do I get the line that is perpendicular? What kind of slopes do perpendicular lines have? Well, they are opposite reciprocals. My original is -1/2. My new one, the opposite of negative is positive. The reciprocal of 1/2 is 2. I'm going to substitute that in to my equation. Y is equal to 2x plus b. Now I've got to find b. I've got an x and a y here, so I'm going to substitute them in. 2 is equal to 4 times 2 times 4. We're substituting in the 4 for x. Plus b. 2 is equal to 8 plus b. Now, we've got to subtract 8 from both sides to find b. -6 is equal to b. We're going to take our equation, we're going to bring it down. Y is equal to 2x minus 6. Where do I begin? At -6. How do I move? Go up 2 and right 1. 2 is the same as 2 over 1. I start at -6. I'm on my y-axis, -6. I go up 1, 2, and over 1. There's my next point. Go up 1, 2, and over 1 again. I've now got 2 more points I can use. So as you're looking at it. Now, this is where my 90-degree angle is. I'm going to mark it because in geometry you're taught to mark what you know. Those lines are perpendicular because I told you so and because the slopes prove they're perpendicular. Okay, perpendicular. Can you pause the video and graph the first equation, graph that equation? Well, I hope you tried on your own. If you didn't, please pause the video now and try. Yeah, I do hope you did. So where do I begin? At -2. How do I move? I go up 2 and right 3. So I start at -2. I go up 1, 2, right, 1, 2, 3. If I want another point, I'll go up 1, 2, right, 1, 2, 3. I am ready to graph. Okay, now for the next one, I've got to find that equation that I need to use. Step 1 is to identify the slope. Identify the slope that will be perpendicular to 2/3. Remember, our new slope has got to be the opposite. This is positive, so it's got to be negative. The reciprocal of 3 over 2 is 2 over 3 is 3 over 2. Put that into our slope-intercept form. Y is equal to the opposite of 3 over 2 plus b. Now we're going to find b. Okay, 6 is our x, negative 4 is our y. Negative 4 is equal to negative 3 over 2 times 6 plus b. Negative 4 is equal to negative 6 divided by 2 is 3. Negative 3 times positive 3 is negative 9 plus b. I can now solve for b by adding 9 to both sides. These are opposite symbols, so I subtract. 9 minus 4 is 5. 9 is positive, so 5 is positive, plus b. Now bring my equation down. Add the b in. Y is equal to negative 3 over 2x plus 5. Where do I begin? I begin at 5. How do I move? Down 3, right 2. Find your 5. Go down 1, 2, 3, right 1, 2. Go down 1, 2, 3, right 2. We're ready to draw the line. These two lines are perpendicular. I'm going to put my little symbol that says they're perpendicular right there. Hopefully, after the first one, you were able to do the second one on your own. If not, you need more practice. Okay, find the line that is parallel to the given line and graph both points on the same Cartesian plane. So if I'm looking at d of x is equal to 5, what are some of the points that will be on here? Okay, so we know that our output, no matter what the input is, our output is 5. So if I had 0, it would be 0, 5. If I had negative 2, it would be negative 2, 5. What about positive 4? It's still going to be 4, 5. Let's graph this and see what it looks like. It is what kind of a line? It's horizontal. So if it's perfectly horizontal, what is our slope? It's 0. So I've got to have well, this one isn't going to work out very good because it's the same line. Let's change this to a negative 5. Negative 4, negative 5. So I'm going to go over to negative 4, I'm going to go down to negative 5, and I know it's got to be that horizontal line again. These two lines are parallel. They've both got zero slopes. They both go through the points indicated. Okay, so the last one is to get you to think about what happens. So as we're looking at the first one, f of x is equal to x squared. So as I'm giving myself points, when it is 0, 0 squared is 0. When it is -1, -1 squared is 1. When it is 1, 1 squared is 1. When it is -2, -2 squared is 4. When it is +2, +2 squared is 4. So I'm going to graph these to begin with. This is my x squared. 0, 0, -1, 1, -2, 4, 1, 1, 2, 4. Now, here we go. It's going to go down and it's going to go back up. What happens if we multiply by 2? What's it going to do to those last numbers? Well, if it is 0, 0 squared is 0 times 2 is 0. If it is -1, -1 squared is +1, +1 times 2 is 2. If it's 1, the same thing happens. If it is -2, you're going to end up with 4, and it's going to be 2 times 4, which will give me 8. If it's +2, the same thing happens. So, 0, 0, -1, 2, 1, 2. Then if I got to -2, it would, here's 7. So -2 would be about here. +2 would be about here. So if you notice, where does this fall? It has pulled it, it's stretched it, and it becomes bigger quicker. Okay, what about if we multiply by 1/2? Okay, when I used 0, 0 squared is 0. 0 times 1/2 is 0, so it's 0, 0. What if I put -1 in there? -1 squared is 1. 1 times 1/2 is 1/2. And the same's going to happen for 1. Okay, what about 2? At 2, 2 squared, -2. -2 squared is 4. Half of 4 is 2. 2 squared is 4. Half of 4 is 2. What about 3? -3 squared is 9. Half of 9 is 4.5. 3 squared is 9. Half of 9 is 4.5. So we can actually do a few more points. When we get to 4, 4 squared is 16, half of 16 is 8, and we're off the chart again. 0, 0, so they all start at the same place. -1, 1/2, so now I'm down here. 1, 1/2. -2, 2, 2, 2. -3, 4.5. 3, 4.5. See how it gets flatter? So what do you notice? The fraction made it get fatter. It did not go up as fast, so the fraction made it compressed. I'm going to call it fatter. Okay. How do you know you're successful? I know I'm successful when I can identify lines that are parallel, perpendicular, or neither from equations or from graphs. Parallel, perpendicular, vertical, stretch, or compression.